Kia ora Year 10. This is one last video to help you go over studying for 1.4. This video is going to look at how we write equations from word problems. We've done this heaps and heaps, but I think some of you are feeling nervous and you are having trouble remembering what to do. So let's look at what we know. I need to make this a bit bigger. When we started this topic, we looked at writing equations without any word problems, and we got good at doing this. We know that y is equal to mx plus c is the equation of a straight line. So m in here, the number m, is the gradient, and that tells us all about how steep the line is. So when we've got x going up by 1 unit, y will go up by m units. Now, how did we see that? Well, the first way we looked at it is when we had a table. We might have x and we might have y. Right, so if y is equal to 2x plus 1, we could put in our x values here, and then we can work out our y values. So we get 1, 3, 5, 7, and we can see that it's going up in twos. So every time x goes up by 1, y goes up by 2. And that's what it means to have a gradient of 2. Okay, so if this number in here is positive, then as x goes up, y goes up by m. And if it's negative, it goes down. And if m is 0, then y doesn't change when x changes. So that's how we see it with a table. But of course, the main way that we used in this topic was to look at a graph. Right, so I'm not going to do too many graphs in this video because my main focus is on word problems. But let's just remember how we wanted that to look. There, that's good enough. Right, so if we've got y equals 2x plus 1, we know that the y-intercept is this number here. It's 1. And the gradient m is 2, which is the same as 2 over 1. That tells me that if I go out 1 here, I need to go up 2 here. And then I do it again. Out 1, up 2, like that. And then we can join those dots up. Now that's a really, really bad idea to do that without a ruler. So, but that's what it looks like. Okay, so that's the graph of y equals 2x plus 1. If we've got a gradient of 0, then the equation of my line will just be something like this. Y equals 3. And that means that the y value doesn't change when the x changes. And so that one, I don't know what's happening there, right? So then my line looks like this. So it's a horizontal line. And we got really good at knowing what that means with word problems. That means that nothing is changing in the y value, no matter what's happening to the x value. Okay, so if I get time in this video, I'm going to come back to these. But these are all different x and y straight line equations. So the number next to the x is the gradient, right? So in this one here, the gradient's 12. In this one here, the gradient is negative 10. And in this one here, the gradient is 0. And we've got a flat line. The number stuck on the end is the y-intercept. And that tells us the value of y when x is 0. But that's all very abstract. So let's turn it in now to what we do with word problems. Okay, so when we're looking at a word problem, the first thing that can confuse people is that we often don't have variables that are x and y. We'll change them. We might have things like this. We might have h for the number of hours and e for the amount that someone earns. And that means that my equation will start off e equals something times h plus a number, right? This will be my gradient number, and this will be my y-intercept number. Or if we're doing a question about the post office, we might have the cost of a parcel, and it might depend on the weight of the parcel. So then we'd have c is equal to something times w plus some number here. Okay, so if we were doing this one about the post office, and we had c and w as the variables, then when I do my graph, the letters would be c and w, right? So I'd have w here, and I'd have the cost here. And this box here, this number on the end, would tell me where to start my line. All right, so this thing here is called the y-intercept. This is called the gradient. And the gradient tells me about going out and then up, and then joining those points up. Okay, so now finally what we're going to do is we're going to look at some clues that tell you what the gradient is from the words. Okay, so the gradient is telling us how something is changing. So it's a rate. And keywords are often for every or per. So if you see the cost per song in a question, that's telling you about the gradient. The pay rate per day. As the days goes up, what happens to the pay rate? What is the cost per kilogram? What does it cost to send an extra box of chocolates? So that's a clue, oops, wrong pen. Saying an extra is a clue that as the number of chocolates goes up by 1, the cost is going to go up by some amount. What does the plumber charge per hour? And what does the electrician charge per light bulb if she changes light bulbs? And then when nothing's happening, that's what the y-intercept is all about. So here are some to try out before we look at how to draw the graph. So the first step is to try and write the equation. So let's just go slowly through these. I'm just going to make them a wee bit bigger. Okay. All right, the plumber charges $40 per hour. Write an equation to model this. Use C for the cost and H for the hours worked. So $40 per hour means that the gradient is 40. And there's no call-out fee here, right? The plumber just gets $40 an hour, and that's all there is to it. So that means that my equation is really simple. C, the cost of the plumber, is going to be 40 times H, because we were told to use H for hours worked. So now if someone said, what if you got a job done that took 5 hours, show what it would cost. You take the 5 and you substitute it in where the H is. So you'd go C is equal to 40 times 5, which is $200. Okay? So that's that first equation done. Right, no y-intercept and a gradient of 40. The next one, babysitter charges $15 per hour. Write an equation, use C for the cost and T for the time in hours. So this time the equation would be this. C is equal to 15T. On my graph, I'd have T here and I'd have C here. And there's no y-intercept, right? So for 5 hours, we'd have T equals 5, right? And we know that the cost would be simply 15 times 5. So for both of these, there isn't a y-intercept. So the graph is going to start here at 0, 0. And we could also do that into a table, right? So here's my table. We've got T here and C here. This is for the babysitter one. So for 0 hours, they don't have to pay any money. For 1 hour, they pay $15. So 15 times 1 is 15. It goes up by 15 an hour. 15 times 2 gives us 30, right? And so on. And you can see when we get to 5, we'll have a $75 cost. Right, so the gradient here is how much it's going up every hour. Now there's no y-intercept because there's no amount to pay for no hours of babysitting. But in the next question, I've changed it. Suppose we've got a dog walking service and it charges a flat rate of $100 per month. This lets the people who use the service use it as many times as they want in that month. So this equation is going to be really, really easy. We have to write an equation linking the cost and the number of walks your dog goes on. So we're going to call the cost C and the number of walks W, right? But we know that it doesn't matter how many walks, the cost is just going to be $100. So that's an example where the gradient is 0. So the cost does not change. So let's just go over what we've got so far. For the first two, we've got no y-intercept. So this one will be c equals 40h. For the babysitter, it'll be c equals 15t. And for the dog walking service, it'll be c equals 100. Right, the next one is one that we've looked at lots in class. We've got an electrician who charges $38 per hour. That's the gradient. So my equation will start off as, we're told to use E for earnings and H for hours worked. So the equation will start off as E equals, the gradient's 38, so it's going to be 38 times H, and there's a call-out fee of $20, so it's 38H plus 20. Right, and the next one, we're sending a parcel to Australia. There's an initial cost of $5. So that means even if it doesn't weigh anything, it's going to cost you $5 to send the parcel. This is the hardest one I've written here. So there's a cost of 10 cents per 100 grams. So if it's 10 cents per 100 grams, we want to get a per 1 unit of something for our gradient. And so if it's 1 kilogram is 1,000 grams. So we're going to times that by 10, and it's going to be $1 per extra kilogram and an initial cost of $5. We need to write an equation using C and W. So C will equal 1W plus 5. Now we never write the 1W in algebra, so it will be just be C equals W plus 5. And that works because everything is in dollars. Okay, so let's look back at that one again. The words in there that tell me I've got the gradient is this cost per 100 grams. That's the gradient. Okay, up here the gradient is $40 per hour, $15 per hour. In this one there's no gradient. Let's look at the next two. To send the parcel to Indonesia, there's an initial cost of $12, then a cost of $1.50 per kilogram. Use C and W. So this will be C equals 1.5 times W plus the initial cost of 12. That's my y-intercept, 1.5W plus 12. Okay, the next one is another dog walking one. There's a plan where you pay $15 per month and then you pay $2 every time you get your dog walked. So that's the gradient. Okay, so the equation for that last one is going to be this. C equals 15, I don't know, let's put W for walks. 15 times the number of, no, that's not right. 15 is my y-intercept. $2 is my gradient. So it's going to be 2W plus 15. So that's how we go from the words to the equation, and that's long enough. In the next video, I'll go over how we draw the graphs.